Okay, let us see what we are going to do for today. Today I'm going to introduce some parts regarding the coding and logic parts gate. We will work more on these two parts on next two lectures because we learn something and then we should extend it for the future lectures. Okay, first of all, let us speak why we need the coding part and what is the use for this coding. Actually, the main purpose of having the coding part is that people wants to transfer the data. Um, Means that suppose if we want to speak together just right now, we are using the one coding system, and that coding system is English language. Something that you can understand, I also can understand if you reply. But sometimes suppose it will happen that any of us have some mother tongue, we have one mother language that we just know, or limited person know that language. If we speak with that language and none of you suppose know that, this coding, it will come in the method of coding that just few people will understand it. Okay, they think that coding is something like sending them message, and even I read some articles that in them clearly they mention that suppose during the war, people using the coding, and by using the coding they will send the message, some critical and important message together, and then by the help of that method they could send some, they could secure the data. Currently also we have this coding part. Suppose when you want to enter to any web page, you will see at the bottom of web page there is some key that after entering that it will script it, it will put it in the format of some codes that based on that codes they can validate you that are you robot or you are human, some activity like this, some personal job or some special job like that, which we can call it again, it's something like coding part. Anyway, last lecture we talked regarding the signed binary numbers and we review three methods. One was that two's complement, one was first complement, and another one was sign magnitude. These numbers also we can call them some parts of coding. Suppose if I want to send the data with positive or negative value, I can use any of them. And even in the task number 4, as I give it already given to you, and some of you solve it for me, you see the main difference between them, and even main limitation between the signed and two's complement methods. Um, Binary numbers and binary codings are more demands because we have the flexibility of representation. And within the constraint below, we can assign any binary combination called a code words to any data, as long as data is uniquely encoded. Also, another point to using the binary coding especially is that we can have the information type, some numeric we can have and some non-numeric. Is that in the numeric type, we must represent the range of the data which we needed, and it's very desirable to present the data such that simple, some straightforward computation for common arithmetic operation permitted. And we can have the types relation to the binary numbers. Suppose for the data type, which are non-numeric, greater flexibility since arithmetic operation will not be applied, but not tied to the binary numbers. Non-numeric binary codes sometimes can come in the uh, other sense or other words. Suppose if we have the given n binary digit, which we call it bits, a binary code can be the mapping of representing elements. And you know that if you have n bit, you can have two power by n binary numbers on that. Suppose if I want to shows a binary numbers for 7 color which we have in the rainbow, simply I can give them the binary numbers like 00001 01001 something like that, and you will see that the number 100 cannot be used because now we are limited to 7 color. What I want to say that is that even for non-numeric we can have some relation between the binary systems and that elements. Anything can be coded like this. Remember the var, remember the coding, remember the sending the message. Then maybe you will see that the relation between the binary and non-numeric system is better. Anyway, but what about binary coded decimal, or which people will call this as BCD? You know that all those binary data is the most efficient storage scam. Every bit pattern represents a unique and valid value. However, in some application may not be desirable to work with the binary data. For instance, the internal components of digital clocks will keep the track of the time in the binary. The binary value then should be converted to the decimal before it can be displayed. Then we can say because of digital clock is preferable to store the value as a series of decimal digits, where each digit is separately represented as its binary equivalent. The most common format which we use to represent the decimal number can be the binary coded decimal, or BCD, which we are going to discuss regarding that. It's not difficult, it's just each bit can represent separately, or each number or each digit can be represented into the binary, and then we will show separate binary related to one number, which people will call it BCD number. The BCD numbers codes is has the value with 1248. What I mean is that the first bit or first digit of the seriesum number have the value of 1. The second one has 248. Already you know this 1248 arrangement because we have done lots of work on the binary to decimal and decimal to binary. And this weightage is something which is not new for us. We know that. That is why the BCD number people will call it as the weighted code. Means that each uh, bit in the digit has the weightage, or if you remember the first lecture that we had, each some I mm, tell you the word as the GPS. Okay, means that any point in the world has the longitudinal and some special location in the word. Any digits in the any bit in the digits also can have the special weight, can have the special number and value, something like GPS thing. This code, people will call it simplest because most intuitive binary code for decimal digits and uses the same power of 2 as a binary number. But only something that we have is that each digit can be represented in the form of 0 to 9. Means that suppose if I have the number 1 to 4, or 124 in the decimal format, each each these digits, suppose digit 1, digit 2, and digit 4, any of them should be represented between 0 to 9. And we can have, suppose, some example like these that we have uh, here, that we have 1001, which can be the addition of 100 plus 001. What does it mean? It means exactly the 1001, it's equal to number 9. How we say that it's number 9? Because as I tell you, uh, let me write for you here: 1001, it's equal to, first one value or first weightage is 1, second one is 2, next one is 4, and another one is 8. Then if I do the addition between them, I have 1 multiplied by 8 and 1 multiplied 1, which equal to 9. Okay, this number. And you know that it's very simple, that because 1000, it's equal to 8, because I have 1, 2, and 4, and 8, which my numbers become 8, and another one is 1. It's summation of this. But can we say how many invalid codes we have in the world, and what are the invalid codes words? Uh, it's maybe a little bit difficult to say. Let us discuss more regarding the BCD numeric format. What we have, that we have the numbers between 0 to 9. 0 to 9, just you convert it into the binary, which even I shown here for you. And for the numbers more than 9, we don't have any value for the BCD. Okay. Most of the time, people try to show the BCD digits with the 4 digits, and you will show. Later, I will tell you why we have just between 0 to 9. Let me, uh, in short, describe for you why we have 0 to 9. Because we have one element that we call it 7 segment. It has the 7 parts. Maybe some of you show it on your calculator, okay? And you will see it's something like 8. With this arrangement, the numbers that you can show, one is 0, which I will show it like this, and another number that I can show maximum is 9. You know, I cannot show the number 10. If I want to show the number 10, I should use 2 digits like this. One is I can show just this part, and another one is this. Then it's become 10. And similar way for them, numbers more than 2 digit, 3 digit, 4 digit, like that, we can use it. These terms or this element, we call it 7 segment, and later we will discuss and also solve some question based on this element. Okay, then what is clear till now, that we are going to say the BCD number is just conversion between 0 to 9 and representing any digits between 0 to 9. Okay, one example, suppose 253 in the decimal, we want to convert it into the BCD. Let us do it together. Okay, I will start from 2. Okay, 2 is nothing by 1, 2, 4, 8. Yes. Then with this arrangement, if I want to show the 2 is 0010. What about 5? 1, 2, 4, 8. Similar, 4 plus 1 is 5. And for the 3 is 1, 2, 4, 8. 2 plus 1 is 3. Okay. Then you will see that it's not very difficult. Then what we should do for the positive or negative numbers? Suppose if I had the plus 27, or if I had the negative 27, what should I do? Hmm. We should use one sign bit for that, which represent the number, is it positive or negative. Suppose this term will show me the 7, and this term will show me the 2, and one separate bit will show me the positive or negative. If in my application I want to show the positive or negative numbers, I should have one specific bit for that. But remember that BCD does not store the negative numbers in two's complement. This is the some critical point that we will talk regarding that later. Do we have any other formats for the codes? Yes, we can have any arrangement. Suppose I can have 1224. What does it mean 1224? It means that first digit has the value or weight of 1, second one has the weightage of 2, third one again have the 2, and 4 has the 2. Okay, now suppose if I want to convert the number, suppose 4, with this value for 1 2 2 4. Okay, simply I can say that 1 0 0 can represent the this coding system. Suppose if I want to show the 7, okay, 4 2 2 1, it's equal to 1 1 0 1, like this. Okay, and we can continue like that. Okay, let us continue for the next. Another coding system that it's more useful, and just today I will describe little bit regarding that. You will solve some question, and later on we will discuss more, is gray code. As you see, as you see in the gray code, and as you see in BCD code, I mean in pure binary coding, which we are using the weightage of 1248 or 8421. It depends on from which side we will read it. Um, we can count the number of 7 to 8, which will require the 4 bits. And based on this BCD code, you will see that bit by bit it will change. What I mean? I mean that suppose if my number is 0, the difference between 0 and 1 is just between 1 bit. And between 1 and 2, it's another 1 bit change. With 3, you see, again, 1 bit is changed. 1 bit by 1 bit by 1 bit, everything will change. But gray code is avoid these things. Only 1 bit change between the subsequent numbers. Suppose if this is my gray code, which it's with gn minus 1 and g1 g0, any number of digit, and it will shows the binary numbers which will start with bn minus 1 till b0. I can have this formula which it will shows that gi is equal to bi plus 1. This is not real plus. This we call it XOR or exclusive OR, which we will talk uh, regarding this exclusive or even today, and I will show you how to use. And vice versa, if I want to convert the binary numbers to the gray code, we can have the bn minus 1, which is equal to gray gn exclusive with gn minus 1 plus gn minus I, and then bn is equal to gn. Like this, we can do this conversion. Little bit more, we will go. As we count up using the binary codes, the number of bits that change from one binary value to the next will vary something like this. 00, just 1 bit change. 001, 2 bit change. 011, 3 bit change. But in gray code, only 1 bit will change. as we count up or count down. See, I show you the table which is here. You can sense the difference between binary and gray code. And in that, we shows that suppose binary code is 0040, it's okay. For one is okay. For two, binary code. Now I should change one bit. I can change one bit here. For three is like this, four is like this. I don't want you to memorize this. We have the formula as we show, and you can really with very simple calculation you can solve it. But just I want you to see the difference between this number and previous one, this number and previous, and you will see that it will change only one bit as we count up or count down. And binary is the reflected code. Hmm. The gray code also can be used in low power logic circuits that count up or down. And because only one bit will change, then using this gray code will help us to save the number of internal secrets that we need inside of our ICs. This we will talk later, uh, and then you will see the difference between the uh, I mean the internal design circuits. It's not uh, our what we can say. It's not much more the core of our course, but I will try to give you some VHDL and very large language examples this semester. Even I plan that you will become familiar much more regarding that. Generally, we have some lectures that they call it FPGA, and by that FPGA course, you will learn much more regarding the internal circuit. Here also, we will do the design, but real implementation with the software and also optimizing that it's need another course. Anyway, I will try to give some example like that. Let us see this. Suppose I have the number 1000110 as the binary, and I'm going to show the gray code for that. The rule of gray code is like that. First, I will put the first digit as it is, and then add the leftmost binary code to the adjacent one, something like that. I will do 1 plus 1, then it's become 1, and then 1 will come here. Now I should do the next. This one plus this one, it's become 1. Then I will should do the next. This one plus this one, it's become these, and this one from this one means that one bit by one bit I will do the addition, and then we can do. Let us do one more example. Suppose I have one gray code. I want to convert it to the binary. First, we will do the number 1 as it is, and then we will do 1 plus 1, it's become 0. Okay, next is 0 plus 0, it's become 0. We will continue. 0 plus 1, it's become 1. Okay, continue. 1 plus 1, it's become 0. Continue. 0 plus 1, it's become 1. And then finally I can have this number equal to the concern gray code that we had before. um, Let us see the application of this coding. I tell you that sending the message is one, but the main things that we will do is shafting coder. Shafting coder is the tools that people will use to recognize the speed of motors. Maybe in your bike, maybe in your automobile. Even in automobile, currently it's a little bit different nowadays, but we can say that it's a little bit similar. And with that, there is one um, surface, which is generally it's rounded one, and then they start to do the special coding for that, something like this gray code that I put here, and they will see and read the code. How they will read the code also, it's not difficult. It's simple. With the help of sensors, you can see how many uh, black and how many white you have. As you know, black is 0, white is 1. Then they based on counting that, they can estimate the speed. We will talk more regarding this part, and we will see that how this shaft encoder will work. Here I show you the place of shaft encoder in the, suppose, in the DC motors, and based on that you will see that the sensor is here and it can sense and also count the number of rotating through that. Okay, another code that we have, they call it 3 BCD code, exists 3. Exists 3 is very simple. Whatever code that you had in BCD, just plus it with 3. Hmm? Suppose instead of showing the 0, I should show 0 plus 3. Then 0 initially is 0. Instead of showing the 1, I can show 1 plus 3. Then I should start 4. Hmm? For 2, 2 plus 3, it's equal to 5. Like that, I can show it, and it's very simple. Means that we can say BCD plus 3, or as they say, exists 3 is another coding method that people can use it. Okay, let us see some examples. Suppose if I want to convert 85 to exist3 BCD code, how should I do? First is 88. First is 8. Another number is 5. Then it's very simple. 8 I should plus with 3, which is become 11. 5 should plus with 3, which is become 8. Then simple. I will convert 8. I will convert 11 to the BCD, and you will see that 11 in BCD is 1011, and 8 is 1000, like that. Then 85 can come 1011, and 5 can be 100. Simply, this is 5 and this is 8. One more example. Suppose if I want to shows the number 13 with exist 3 codes. Very simple. I should add each digit with 3 and then show it with BCD. First bit is 1. 1 will add with 3, it's become 4. I can convert it to binary. Another one is 3, which can be added with 3, it's become 6. 6 can be converted to the binary. Um, Even more digit, if I want to do the 430, like that, same algorithm I have, I can add it with 3, each digit, and then convert it to the BCD, as you can see here. Then, meanwhile of this coding, there is one part or one thing that we should consider, and that is parity. What is parity and what is the use of parity is somehow it's critical to finding the error. Okay, we have some name that they call it parity, and uh, based on that we can find it as the error detection system. Parity is nothing but extra bit which is added to the data word, and the new word is then can be transmitted with the help of parity. Two systems we have with the parity. One is that even parity, and another one is odd parity. Even parity is the system which is that the number of one must be even, means that in my number, and odd parity is that number of one must be odd. Hmm? And simply you can see from the example that I put it below and I compare the number 11001. In this number, as you can see, even a number of 1 is even, and in this one, number of 1 is odd. Okay. How it can help? It can help like that. I know that in my transmission protocol that the received number should have the even parity, or the received number should have the uh, odd parity, and then we can convert it. Okay. Um, as I tell you, the use of parity bit error is something like that. We can have the redundancy, for example, for extra information, and in the form of extra bit, it can be incorporated into the binary code word to detect the correct error. And a simple form of redundancy is the parity, which is an extra bit appended onto the code word to make the number of first odd or even. Parity can detect all single bits error and some multiply bit error also. Then a code word has even parity if number of ones is even, and it has the odd parity. The number of ones in the code words is odd. This is the main things that you should remember from this parity section, which is not difficult. Then what we learned that parity is nothing but extra code that we just use it to detect that the received code or transmitted code is correct or it has error. Then can we have 4-bit parity code? Yes, it's very simple, something like this, that we can see the even parity and odd parity through that. As you can see, the code 111 has the even parity and 1110 has the odd parity, and both can be used for 3 bits data. Suppose I have 3 bits data. If I want to use the even parity, I can just use add 1 at the end. And if I want the odd parity, I can use the 00 as the end, which my received message can detect that it has the error or don't have. Mainly these parts means that parity one will use when suppose you want to do the transmission with the serial communication protocol or SPI or I2C and transmitted protocol, which is more famous in embedded system. Okay, let us see all these binary codes and decimal codes, what I tell you till now, in one table and compare them. Suppose if I have the decimal number of 0, I can show it with BCD of 1, 2, 4, 8 or exist 3, or I can even show you with this -1, -2, 4, and 8. Means that the weightage is different, or I can show you in the gray code. Okay. Um, I will advise you to test and do this table uh, once with your hand, and then you will sense the uh, difference between these parts. And what I will do, I will put a screenshot of this, and as the homework assignment for you, no need to send for me. I will put it in the group. You can do that, and then even already just right now I put it in our WeChat group. You can follow that and do it with your hand. Then you will see the difference between the code. Anyway, we have one more famous coding system that all of us know it. We call it ASCII code, which meanwhile of ASCII code, which is the standard for American standard code for information interchange, and it will use 7 bits to encode 128 unique characters. Okay, A, B, C, D, E, at sign. Any character can be shown with the ASCII code. And mainly in your textbook, suppose it's written there. And as a note, formerly work to create the codes will begin in 1916, and first standard it's become in 1963. And in um, 86 year, it's again updated as the last. This ASCII code is exactly the code that we use in C language that we had, and it's more famous. No change for that, and even I think somehow no need to memorize them because there is a table for that. Anyway, but you should know how it will come and it will show. Suppose some range you should know that from the space dollar questions parentheses plus minus multiplication, and it will start with 0 1 0, and with control character like escapes and like that it will start from 0 0 or 0 0 1. Okay, let us say suppose some ASCII code, something like I want to encoding the number 1 2 3. You can refer to the table and you will find 1 is how much in ASCII code, 2 is how much, 3 is how much. Or if I want to do the word of Joanna, something like that, that I take from one PPT on the net, you can do it. Note that every ASCII code is 7-bit code. Okay, and also the main benefits and main power for the ASCII code is that alphabet alphanumeric codes, which you can represent the alphabet based on this ASCII code, and you can do it. Little bit, if we want to go ahead with this coding system, we can say that we have Unicode, which extend the ASCII to 65 and 65,000. Um, 536 universal characters codes. And for encoding the characters in the word language, we can use it, and it's available in many modern application. And currently now it will use with 16-bit as you see. Okay, till now, what we discuss? We discussed regarding the coding system and different coding part, which we will add some more for the next lecture again uh, regarding the coding system. Now, if you have any question regarding that, we can uh, discuss regarding that. Otherwise, I'm going to continue for the logic. Do you have any question? The second important part for today is logic gates, which it's something like symbolic showing of the arithmetic part that we have. This part is, we can say, the initial gate for our lecture, and something that we should know much more. It's very important, and it's very simple part that all our future lectures depend on this a small part of our lectures. I mean that whatever we will do after this, with the help of these logic gates. Logic gates are nothing but symbolic showing of gates, or symbolic showing of the uh, symbolic showing of the um, arithmetic words. Let me turn Victor off. Then, oh. First, the first thing that we learned that we call it and. And gate will represent with this symbol, and as you see, we are using two bits. One is A, another one is B, which with the help of these two, we are going to showing the performance of this gate. If I have 2 bit, how many number I can show with the value of 1 and 2? I can show 0, I can show 1, I can show 2, and maximum is full 2 bit, which is equal to 3. Okay, and is nothing by multiplication between the numbers. you know 0 multiplied by any number result is 0, and 1 multiplied by 1 is just 1. Okay, then we can say that AND gate with two inputs result is 0 in all the case except that my two inputs is 1, and we will show it. Another one is or is equal to add. What I mean that 0 plus 0 is 0. 1 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is also 1. Okay. Last time, if you remember, we said 1 plus 1 is 1, 0. Now we don't have that part. We can say 1 plus 1 is also 1, which we will shows this as the OR gate. Okay. Next gate is not. Not is that whatever gate that I have, complement of that is at the output. Suppose if I input 0, then my output is 1. And if I put 1, my output is 0. Okay. Can I make this gate not gate from other gate? Yes. You can make with AND gate, which both gate us together. And this part, as you see, we call it bullet. This is the part which will make the gate not, or will make the complement of my input. Okay. um, Not gate is very important because it can invert of input, and also it can be very useful to reduce the noise from any design system. Remember just this point, we will talk more. Okay, then if I want to show the working table or this table, from this time we call it truth table. Truth table is the table which shows the performance of any logic operation. As already I show you A and B or X and Y, there is no difficult what, there is no different that which name you will put for the input. 0 and 0, and of them are 0, and just 1 and 1 is 1. And with the OR gate also, you will see that 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. Means that in all the case is 1 except that 0 and 0. And not also we review. Okay, there is one more format that we are going to show for the uh, truth table. Instead of showing the 0, 0 as the form of table, we can show it in the form of wave. Hmm? If you see this X and Y, 0 and 0 is exactly equal to the previous table that I show you. Okay, and then and of 0 and 0 is 0. 1 and 0 and is 0. 1 and 1 and is 1. 0 and 1 is 0. And 0 and 0 is like that. Then I can show it in the form of waveform. Same way, if I want to show it the OR, you know that OR of 0 and 0 is 0. 1 and 0 is 1. 1 and 1 is 1. 0 and 1 is 1. And 0 and 0 is 1. And if I want to show the not of, suppose, X, whatever X I have, I will do the inversion. Means that in the case that this is 0, all of them are 1. In the case that all is 1, we can have 0. And in the case that we have 0, all are 1. Okay. Then I have two way. One is that table, another one is waveform. Okay. These two things, please remember, we will work more in this lecture with it. Can I have multiple inputs for the gate? Yes, I can have 3 or more, and the gate shape can be like that. Okay. Now, three main parts was and, or, and not. If I want to mix them, what I should suppose, if I want to put not and, it's become NAND. Means that whatever was the output of and, if I put one not gate for that, I can put it as the NAND. Means that this gate is the result of this symbol, which people will call it NAND. If I have one and plus one not gate, then we will test 0 plus 0 and 0 and is 0, then NAND is equal to 1. 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0. It's something like that. What about NOR? NOR is example, same with the same logic. It's a combination of OR and uh, NOT, which with this combination, we can shows the same. NOR of 0 and 0 is not OR of 0 and 0, not OR of 0 and 1, not one OR as 1 and 0, not OR and 1 and 1. It's very simple, then you can solve. Okay. What is little bit different is exclusive OR. Exclusive OR, it has some specific rule, and rule is that if my input are not same, my output is 1. If my input are same, my output is 0. Okay, simple. If my inputs are not same, means that one of them are 0, one of them are 1. Just my output is 1. And we will show the exclusive OR with this symbol. Okay. Another one is EXNOR. If I put one and, one not, after this XOR, it will come. Then in exclusive NOR, if my output are same, my output is 1. Okay. Then when my output input are same, when A and B are 0 or A and B both of them are 1, then you will see the XNOR gate for the as I showed here. Okay. Please note that NAND and NOR gates are, we will call them as universal function, since either one uh, and an or function and not can be generated. A function in some of the product, which we will see, we call it SOP, from can be implemented using NAND gate by replacing our and OR gate and by NAND gate. A function in product of sum also can be using the NOR gate by replacing all and OR gate. These sum of product and product of sum, we will talk more in future. Let us see all the gates that we have today. Means that the main things from today lecture is this one that again I will share it in our lectures group, and you can see that all the gates. I think that again you please do this as the assignment with the hand. No need to send for me, just you do it yourself. We have much more assignments that you should send for me. After the lecture I will share it. Okay. What about 3 gates? 3 gates is also like that. If I have AND of 3 gates, 0 by 0 is 0, 0 by 0 by 1 is 0, 0, 1, 0, because we have one term of 0 is 0, 0, 1, 1, 1 as the input. Again, output is 0. In the case that we have 0, in any case, any part of our inputs, output is 0. We just have one case, which is output is 1, whenever all my inputs are 1. It's very simple. Same things I can have for the and with the AND gate, uh, we will see the same logic for that. How I can do the or making the 3 gates, it's very simple. really the three gates is combination of two gates. Means that if I have three inputs here like that, it means that I can split this gate like A and B and output of that with the C. Okay. Same if I want four input, it's something like that. A and B output with C and output with D like that. Which from this part we will have more discussion and more point on the next lecture. Okay, I think it's okay for today. I see you all. Bye.